In this video, we are going to talk about the different scales of measurement found in a typical statistics course. And it's basically the different ways in which a set of data can be measured. So the first type is the nominal scale data. And basically this form of measurement is more on the qualitative side. It has less to do with numbers. The second one is the ordinal scale data. The third one is the interval scale data, and finally, the ratio scale data. So let's talk about the first one, the nominal scale data. So as we said before, this is a qualitative form of measurement. It's categorical, so it can include names, colors, labels, and things like that. So for instance, we could assign a 1 to the color red, 2 to the color blue, 3 to, let's say, the color green, and the order in which we place it really doesn't matter. Red doesn't have a higher quantitative value than blue. It's all arbitrary. So it really doesn't matter which way we order it. Blue could be number 1 or green could be number 1. It really doesn't matter. And so as you can see, these qualitative forms of data cannot be used in calculation. However, the responses of people to these different colors, for example, can be used in calculation. Here is an example. So let's say if we do a survey and we ask 10 individuals what's their favorite color. Let's say 5 chose red, let's say 3 chose blue, and 2 chose green out of a total of 10. So in terms of percentages, out of that small survey, 50% preferred red, 30% preferred blue, 20% preferred green. So that's one way in which we could use this form of data in calculation. But the individual colors themselves, red, blue, and green, they can't be used in calculation on their own merit, since it's a qualitative form of data. Now make sure you understand this. For nominal scale data, the order doesn't matter. But as you can see, for the other types of data, the order does matter. So let's talk about the second one, the ordinal scale data. So this type of data is typically used to rank basically things. Let's say if you have a race. There's a first place winner, there's a second place winner, and there's a third place winner. In this case, this would be an ordinal scale data because the order matters. However, the differences cannot be measured. The difference between first and second place is not the same as the difference between second and third place. Now, if you're looking at numbers, 2 minus 1 is 1, 3 minus 2 is 1. But that's not the way in which we should really look at it. To illustrate this, we could say that in a race, the person who got first place, let's say he took 4 minutes and 53 seconds to arrive at his destination. And let's say the person who was in second place took 4 minutes and 55 seconds. So as you can see, the time for these two individuals is very close. Now the third place winner, he might have taken a longer time. Maybe he took 6 minutes and 2 seconds. And so the difference between the first and the second place winner is much different than the difference between the second and the third place winner. And so if you don't have the time, you can't really use this data to measure the difference. So this is an ordinal scale data because differences cannot be measured unless you're given this data. So let me give you another example of an ordinal scale data. So let's say if we're ranking experiences, and let's say the options are excellent. The second one is, let's say, good. The third is satisfactory. And let's say the last one is just bad. In this case, we can't really measure the difference between excellent and good. However, we can assign them values. we can give excellent a value of 1, good a value of 2, satisfactory a value of 3, and bad a value of 4. So here, the order makes sense. Excellent is the best, so number 1 has the highest value. Bad is the worst, so number 4 has the least value. But we can't really measure the difference between excellent and good versus good and satisfactory. We just know good is better than satisfactory and excellent is better than good. But to measure the difference, that's not really possible in this case. So this would fall under an ordinal scale data. Now let's move on to the next form of data. So that is the interval scale data. So for this one, the order does matter, and differences can be measured. For the last one, we said that differences cannot be measured. To illustrate this, temperature is a good example. So let's say if we have two temperature values, 30 degrees Fahrenheit and 60 degrees Fahrenheit. And let's say 90 degrees Fahrenheit. So the difference between a temperature at 30 and the temperature at 60 can be measured. That's a difference of 30 degrees. And the difference between 60 and 90, that can be measured as well. That's another change of 30 degrees Fahrenheit. So differences can be measured for the interval scale data. However, ratios, you can't measure the ratios for this form of data. So what do we mean by that? 60 degrees is not 2 times as hot as 30. If you divide 60 by 30, you get 2. But a temperature of 60 degrees Fahrenheit doesn't mean that it's twice as hot as the temperature at 30 degrees Fahrenheit. It doesn't work that way. And so we can't really measure ratios with an interval scale form of data. Now the next thing that we need to talk about is number 3. There is no true zero starting point. 0 degrees Fahrenheit is not the lowest temperature. It's not the absence of heat, because you could have negative values. The temperature could be negative 20 degrees Fahrenheit. It could be negative 40 degrees Celsius, which also makes it an interval scale data. Now, if you're dealing with units of Kelvin, that's a whole different story, but for units of Fahrenheit and Celsius, there's no true zero starting point, since you could have negative values. Now, going back to number 1, the order matters because you can place these temperature values in order. 30 is lower than 60, and 60 is lower than 90. So you can place that in increase in order. So in that sense, the order matters for this form of data. Now let's talk about the last one, the ratio scale data. So for this one, the order matters as well. Differences are measurable, including ratios, and it does contain a true zero starting point. So let's use grades. Let's say the grades that you'll get on a typical statistics exam. Let's say we have the numbers 70, 30, 56, 82, and 90. So the order matters because we can arrange it in ascending order. So we can write it as 30, 56, 70, 82, 90. And the order has meaning. This is the lowest grade, this is the highest grade. Now the differences can be measured. For instance, 56 minus 30 is 26, and 70 minus 56, that's 14. So as we can see, the differences are measurable, and we could also measure the ratios. If we take 90 and divide it by 30, we get 3. And so we could say that this student has a grade that is 3 times higher than this student with the lowest test score. And that would make sense. We can see that the ratios, they're meaningful. And the last thing is true. It does contain a zero starting point. Let's say if we have another student who didn't answer any questions, he would have a grade of 0. So that means that either he didn't do the test or he did the test but got all the questions wrong. And so this it has meaning, it has a value. It means that he didn't get anything right or just didn't do anything. And you can't have a score lower than a 0. You can't have a test score of -20. And so in this case, 0 is a true starting point for this form of data. Let's take a minute and summarize what we've just learned in this video. All 4 forms of data can be labeled. So let's put a check mark for that. Now, the nominal scale data doesn't have any meaningful order. The order doesn't matter. But for the other 3 forms, the order does matter. Now, we can only measure a difference for the interval scale data and the ratio scale data. The nominal and ordinal scale data, we can't measure a difference. Now, the only one with a true 0 starting point is the ratio scale data. For the rest, it's not applicable. And so that's it for this video. That's all I got. Thanks again for watching. Peace.